topic is permutation. Okay, so basically permutation is what? Bijection from a finite set S to itself. So firstly we should know the meaning of bijection. Bijection is nothing, just a mapping which is 1 1 and onto both, then it is called as bijection. Okay, for example, like we are having a set S and we are mapping the set S elements to itself. Okay, and the mapping is 1 1 as well as onto, then that mapping will be called as bijection mapping. Okay, and that bijection mapping from the set S to itself will be called as permutation. Okay, for example, like if we are having a set like, okay, let me just take an example, like we are having set like 1 2 3. Okay, this is the set elements. Okay, and we are mapping these elements to itself. Okay, then this mapping will be called as permutation. Okay, like I have already written, like if you are having like set elements as A, then mapping of those elements like f of A will also belongs to the same set. Okay, elements are also coming from S and the image of those elements are also coming from the same set. Okay, then we call it as permutation. Okay, second we have notations. Like if we are having permutation, then how do we basically write them? Okay, so consider like we are having elements like A, B, C of a set S. Okay, then the mappings of that A, that is f of A, secondly of B is f of B, and for C is f of C. We will write it in this form. Okay, so this mapping A to f of A, B to f of B, C to f of C is called as permutation, represented as f here. Okay, so like once we got the, like we got it, like what is permutation, then we will define that group of permutations. Okay, like basically till now we have like, like we are having, for example, like we are having Z3, we are having elements like 1 2 3. These are the elements and operation is like addition modulo 3. So these elements forms a group under the operation modulo 3. Okay, so here we have got permutations, right? Now we will define the permutation group. Okay, and the operation in the case of permutation group is function composition, because elements are functions of the form this, right? We will notation is f of g, basically function composition. Okay, and these group of permutations are called as symmetric groups. Okay, and the notation for symmetric group is like Sn, where n is the number of elements in the set on which permutations are defined. Okay, and once we will form this group under the operation of function composition, we will have the order of group as n factorial. For example, if we are defining permutation on the set, for example, let's say I'm having the set as basically 1 2 3. Okay, so it has what, 3 elements, right? Then if we define the permutation group on this set S3, okay, so it will be having elements as n factorial. What is the value of n? Is 3, so it will have elements 3 factorial, that is equals to 6. Okay, so in next video we will talk about how to get the elements of S3. Okay, firstly you must know what is permutation, secondly you must know what is permutation group, and thirdly we will get like how to define the number of elements in a symmetric group. Okay, stay tuned for the next video.